This is 2.7, combining functions together, and we're going to learn different ways to combine together, different like f of x and g of x. So let's look at them. So here, the very first one, f of x plus g of x. So if I just wanted to add these two functions, a short way to write it is this right here. So f plus g and then of x. So it means the exact same thing as f of x plus g of x. And the same thing with for subtraction. F minus g of x is the same thing as f of x minus g of x, so this means the same thing as that. And the same thing with multiplication. So here we have f times g of x. That means the same thing as f of x times g of x. And f over g of x is the same thing as f of x over g of x. So just be familiar with how to write it. Again, it's going to be written this way, and you need to know that it means this over this direction. So let's look at two possible scenarios. So here I have two possible functions, f of x and g of x. So here I have f plus g of x. So remember what that means. It means f of x plus g of x. So you're going to literally take these two functions and add them together. And then simplify. So I combine those together. F minus g of x. So that literally means f of x minus g of x. So we have x squared plus 3x, and we're going to minus the g of x. Now, I do want to caution you, real careful, if g of x was longer, like if g of x was something like x squared minus 5x, or something like that. And if you minus g of x, make sure you minus the entire function. So make sure that this is just a monomial, but if it's a two-term or three-term polynomial inside the function, make sure you include the parentheses and then use the distributive property. All right, so f times g of x is literally taking f of x times g of x. And so you're going to take x squared plus 3x, that's f of x, and then you're going to multiply it by g of x. And then you're just going to use the distributive property, so it's 4x cubed plus 12x squared. And this says f divided by g of x, and all that means is f of x divided by g of x. So x squared plus 3x divided by 4x. And of course, you can see that there's an x in common, so we're going to simplify that. So x plus 3 over 4. Now, by the way, a side comment, when you find if I ever ask you to find the domain, make sure that, so some people will look at the domain of this, and you might say, well, the domain of that is all real numbers, because it could be anything. Well, but you have to also look at, before you simplify, what can x not be? So here, x cannot be 0. And so you have to keep in mind that even though this may not have an x in the denominator, the prior step does. G of x does have an x in it. So you have to still include x cannot be 0 in the domain of that function. All right, so let's look at more specifically, so f plus g of 3. So what this means is f of 3 plus g of 3. And same thing here, we're going to do f of 3 minus minus g of 3. F of 3 times g of 3. And f of 3 divided by g of 3. So once we find f of 3 and g of 3, we're just going to plug them in and do the operations, and so it becomes pretty simple once we find that. So because I made these all 3's, it's a pretty simple calculation process for all of them. So if we plug 3 in, we're going to get 9 here, and we're going to get 9 here as well, so 18 is f of 3. And g of 3 would be 4 times 3, which would be 12. So here, f of 3 plus g of 3. So we have 18 plus 12, which is 30. f of 3 minus g of 3, so that would be 18 minus 12. And then here we have 18 times 12 to be able to get to the right, which is 216. All right, so f of 3 divided by g of 3, so we have 18 divided by 12, and notice it can be reduced by 6, so we're going to get 3/2. All right, now let's learn a new function called the composition of functions. And notice what this is. It's kind of like a tiny little O, and so the composition of f and g. So remember when you substitute we talk about the function box. So just as a reminder, if I put 2 inside of f of x, then you literally replace the x with the 2, and then what comes out. So f of 2 equals 9. All right, so just keep that in mind. So really what this means is f of g of x. So if we have the f of x function, that's the same function box, but we're plugging g of x inside of here. So we're literally going to take what comes out is g of x plus 7. So we're literally going to substitute that in. And g of x can be whatever g of x is, whatever the g of x is, but we're going to substitute that in to the f function. So let's look at a few problems. So f of x is x squared, and g of x is x minus 3. So this means f of g of x. So here we're taking the gx function and we're substituting it in to the f function. So again, imagine the function box. Let me use a different color. So imagine the function box f, which is x squared, and we're substituting in x minus 3. So we're replacing all of this with the x. Okay, that's really what this is. So this is f, and then we're putting in x minus 3. So when you replace x minus 3 right here, and then what's going to come out, remember to write this twice, okay, and then FOIL it. So this is going to give you x squared minus 6x plus 9. All right, so let's look at this one. So just the opposite, the composition of g and f. Not f then g, but this is g then f. So you're going to take g, and then you're going to substitute f of x inside of the g of x function. So again, you have the g of x function, x minus 3, and you're substituting in x squared. So you're going to replace this x with x squared. So this one happens to be quite easy because all you have to do is that. So this one, more specifically, you're going to take f and then g of 5. So if we find g of 5 first, so put 5 up here in the g function, and what comes out is 2. So f of 2 now. So now we're putting 2 inside of the f function, so we put 2 inside of here, and what's going to come out is 4.